So next we will come to the discussion of orbits and orbitals. So for this, let's think this is your home. Just let me draw a home for you. Just think this is your home. And this one over here is your school. School generally has a bigger gate, right? And all the classrooms, they have small windows. Oh, sorry, my drawing is pretty bad. So this is your home and this is your school. Now from home to school, you can go either by walk, or you can take a cycle and roam here and there, here and there, here and there, and then you can go to the school. Or when your father is free, he can tell you that come son, we will go by our car today. So you can take a car and you can take a main road and you can go like this, right? So there are different possibilities. From home to the school, the distance is same, but still there are different possibilities, right? You can go simply by walk, or you can go by cycle, or you can go with your father with a car. So different possibilities are there. So similarly, for the electrons also, they have different possibilities or probabilities. So they can occupy different paths or different portions of a orbit. Now let's try to understand the definition of orbit and orbitals. So an orbit is designated as the path for electrons to revolve around the nucleus. So this is actually a two-dimensional conception, that the electron is rotating around the nucleus. So here this yellow one is the nucleus and the electrons are rotating around it. So if I draw like this is the protons or the nucleus, sorry, and in this path the electrons are circulating. My drawing is pretty bad in this one. Actually, I'm using a very bad setup. Yeah, so this one is your proton and your electron is revolving around it. So this is a two-dimensional picture, and this one here is called orbit because this is a two-dimensional thing. And I have just given or designated the path in which the electron is revolving around the nucleus. Whereas an orbital is the 3D space around the nucleus where the probability of finding an electron is maximum. So inside this same path, we have different three-dimensional space. For example, in your case, you can take different travel mode to reach to the school. Similarly, electron can take different 3D space to orbit that nucleus. So an orbital is the 3D space around the nucleus where the probability of finding an electron is maximum. So as we discussed that orbitals are the 3D space occupied by electrons where the electron density is maximum. So inside one orbit there can be different orbitals. For example, when we have orbit number 1, 2 and 3, which are also known as K, L and M. So in that case, in orbit 1 we have only one s, so that is only one orbital, one s. In case of second orbit we have two s and two p. In case of third orbit we have three different orbitals, that is 3s, 3p and 3d. Similarly, in the fourth orbit, we have 4s, 4p, 4d, and 4f. Now, let's see the shape of s orbital. So, s orbital is actually spherical in nature. So, this one you can see spherical shape. This is the shape of s orbital. So, electron density is almost same in the all directions, and it takes a shape of a sphere. Now, this is for 1s. So, if you go to the 2s, that will be a bigger sphere. Compared to 1s, the 2s will be a bigger sphere. Similarly, the 3s will be much bigger sphere. Now let's see the p orbitals. P orbitals are having three different compartments. So these are called px, this one is px, this one is py, sorry, this one is pz, and this one is py. Oh, sorry. So p orbital has px, py and pz, these three different compartments. Now these p orbitals, they look like a dumbbell. You can see in center the electron density is 0, and as you go further from the nucleus the electron density increases. So it actually looks like a dumbbell. So in the center the electron density is 0, and as you increase the r, go along as you go away from the nucleus the electron density increases. So these are kind of like this, dumbbell shaped. So if there is only one dumbbell, that is p orbital, and in case of d orbital there are actually two dumbbells. So as I have drawn this shape, this looks like the d orbital. Now in case of d orbital, so we have five different orbitals. So these are named as dxy, dyz, dzx, dx square minus y square, and dz square. Similarly, f orbital, it has seven different compartments. So these things I will discuss in some later videos. I will make dedicated videos to discuss these things. But for the time being, we will see this video which I have taken from this channel scienceviz.com. I will put this link in the comment or description. If you want, you can go and check this video. It's a very nice video. From this, you can conceptualize how these electrons are revolving. Now, I'll show it. So first we have this electron. Here, this one is the nucleus, or just write P, or proton, positively charged nucleus, and this electron is revolving around it. Now in the 2D space, we can see that electron is circularly moving, but actually in the 3D space, it will be uh, it will create a sphere. So the electron density will be like a sphere. Let's see. In case of 1H, we have one proton and one electron. So the electron is circulating that proton. So in the 2D direction, we can see only like a circle. But when we see the 3D space, it is actually a sphere. And the electron density is equivalent in the entire sphere. So this is in case of proton. In case of 1H, hydrogen. Only one electron. Now if we add another electron, so that means we have two protons and two electrons. We are adding another electron. In case of helium, both the electrons will occupy 1s. That's why we write 1s2 in case of helium. Now when we add another electron, that will come and that cannot take 1s because 1s is already filled. So that will take 2s, and that we get lithium, 3 protons and 3 electrons. Now we add another electron, that will also go and take 2s, so we get beryllium, 2 protons and 2 electrons. Now when we add another electron, that goes in the p to p. In case of boron, that takes p, or it can be sp2 hybridized. This is how it will look in the sp2 hybridization. Now when we add another electron, in case of carbon, it can either take sp2 and 2p. This is the 2p and sp2, or it can become sp3 hybridization. This is how it looks when carbon is sp3 hybridized. Or it can be sp2 hybridized and one electron can be in the 2p. This is how it will look. Or it can be sp hybridized and 2 electrons can remain in the 2p. So this is how it will look. So there are different hybridizations. Based upon that, the electrons can occupy different 3D spaced or different orbitals. So these things, just take a note. These things we will discuss in detail for some other videos in other chapter. So that time I will discuss in details about these things.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.